This is a pretty neat question from chapter 9 in the 9 chapters on the mathematical art written by the ancient Chinese civilization. Show that the diameter d of the largest circle that can be inscribed in a right triangle is given by d equals to 2ab over a plus b plus c, or d equals to a minus c minus b. In this video, we'll go over how exactly this was proven geometrically without any of the modern algebra we use today. First of all, let's tackle d equals to 2ab over a plus b plus c, where a and b are the sides and c is the hypotenuse, with the points a, b, and c. We can start by taking the center point of the circle, or O, and dividing the large triangle into 3 smaller triangles. And looking here, we see that the height of each triangle is simply the radius of the circle, or r. From this, we can say that the area of the big triangle is equal to those 3 smaller triangles. So, we have an equation here, with the 3 letters depicting the triangle that we are referring to. We know that the area of a triangle is 1 over 2 times the base and the height. So, our equation can be expanded out like so. Conveniently, we can cancel out the 1 over 2 in front of all the terms and be left with this. Next, we can factor out the r from the right hand side, giving us this. Lastly, we isolate the r by dividing both sides by a plus b plus c, giving us the radius of the circle. To find the diameter, we just multiply the radius by 2, giving us 2ab over a plus b plus c. Next, let's tackle d equals to a minus c minus b, with the same letter system as before. This time, we write out the radius first, and notice that the length of the triangle here must also be r. This means that the length of the triangle here must be a minus r, and b minus r here. Next, we can draw a line from point O to point B, and we notice that those 2 triangles here are actually similar triangles. We can do the same from point O to point C, and we have 2 more similar triangles down here too. Since they are similar, then the side length here must also be a minus r and b minus r. This means that the length of C is just a minus r plus b minus r, giving us this equation. We can rearrange the equation to isolate the r, and since we already have 2r, this means that this must be the diameter, giving us a minus c minus b. And there we have it! We just proved geometrically that the diameter d of the largest circle that can be inscribed in a right triangle is given by d equals to 2ab over a plus b plus c, or a minus c minus b. This was a fun homework question I had, and thought that it was very impressive that the ancient Chinese mathematicians were able to solve this without the understanding of geometry and logic that we use today. I hope that y'all have learned something interesting today. Thank you for watching, and good luck with everything.